All right, welcome everyone. It's CalPy slash SagPy, February edition 2026, our second for the year. Tonight we have Syrus Akbary, founder of Wasmer.io. He's put together with his team a pretty interesting use case for making things happen quickly in WebAssembly. And once again, I pointed out in our gathering, he is joining us from Spain, which means it is 4:30 a.m. in the morning. So we are very grateful that he has taken it on himself to join us here tonight. So thank you, Cyrus. I'm going to give you the share. Take it away, Maestro.
Awesome. Hello, everyone. I'm Syrus. I will be starting the presentation now. Hopefully, you all can see my screen.
Yep, looking good.
Yes.
WebAssembly,
Yep,
Python, and the
yep,
future
yep.
of AI sandboxing.
Awesome. So today I will be doing a presentation about WebAssembly and Python and how these two mixed together. But before I start, let's do a quick presentation about who am I. That's me when I was pretty young, always playing with Legos. When I grew up a little bit, I created a website that was for watching TV online. About like I think it was 14 or 15 at the time. About 200,000 people visited the website each month, so that was nice. I got my side business when I was at the school. And then basically a few years later, about like 10, 15 years ago, I created one framework for using GraphQL in Python. If you don't know what GraphQL is one specification for creating APIs, similar to REST. This framework is quite popular in Python. Actually, I checked it yesterday. It has around like, I think it was 35 million downloads per month. So it's more or less popular, actually more popular than Django, I believe. And yeah, I started on this quest of Python like long ago. So one of the things that I wanted to do when I created this GraphQL framework for Python is that I wanted to make it universal. I wanted to be able to use the framework from Python, but as well from JavaScript or from other languages like Go, Rust, or whatever. And I was stumbling upon like what was the best way of accomplishing it. And then I stumbled upon WebAssembly, which was this holy grail that promised like one language, one way of targeting basically a lot of different languages and so on. So let's start on like what is WebAssembly actually. I assume not a lot of you know what WebAssembly is, so I'm gonna raise the question, like how many of you do know what WebAssembly is or have used it before?
Heard of it, but I don't know what it is.
Perfect. We'll get into it in a second. Okay, I'm not seeing all the responses, but I will move on, assuming most of you don't know like what WebAssembly is. So about I think it was 8, 9 years ago, there were more kind of complex applications coming to the web, to the browsers, and basically like they could not reach as much fast speed as they wanted with JavaScript. So there was a new specification created on top of JavaScript called ASM.js. And with ASM.js, which was a precursor to WebAssembly, you started to be able to run like some games that were actually created on C, C++, and other kind of programming languages that before you were not able to run it on the browser. They created kind of like a specification to be able to run them. First with ASM.js, which is a subset of JavaScript. And then basically like the teams from Firefox and Chrome teamed up to create a new specification called WebAssembly. So the aims of WebAssembly is to be as fast as native code running in your system because JavaScript is fast but cannot reach as far as native speeds. And they did it with the aim of being able to run basically any kind of application on your browser. One of the special things about WebAssembly is that it's designed to be completely sandboxed. Why is this? Is because you want to make sure that when users visit your website is not going to be able to hack it and then have access to information that they should not have. So they created executable format that was way more safe than what you normally use on Linux, Windows, or Mac. So that's more or less how WebAssembly started. Here is the intro. I'm Syrus. Not only created Within, I also created the company Wasmer, for which I've been working in the last 7 years, and we specialize on WebAssembly. So let's start with what is Wasmer. We are a WebAssembly platform that is composed of multiple things. First, we are a runtime. So if you know what Docker is, the analogy is basically like Docker. Actually, the name Wasmer, it comes from Docker plus WebAssembly. Fun fact, I have not put this on the slides, but the founder of Docker itself, he mentioned that if WebAssembly existed, he would not have created Docker. Fun fact, he's also an investor in Wasmer, so that's a nice thing. So we have the runtime, the analogy is Docker. Then we have the registry. The analogy is what Docker Hub or NPM or PyPy is. It's basically a registry of a lot of packages or containers. And then we have Wasmer Edge. And the analogy of this is Cloudflare. It's Amazon Lambda or Cloudflare Workers, if you're familiar with it. So in a nutshell, Wasmer runs applications as WebAssembly modules instead of containers or virtual machines. So let's start with some explanation about what virtual machines, containers, and Wasmer are doing. So it's easier to understand like where we get the speed gains. So in virtual machines, not sure if any of you have used Vagrant, which was the way of using virtual machines in the old times, about 10, 15 years ago. The issue about that is it was very poor performance. So with virtual machines, you're emulating a whole operating system. And with this simulation, there are some costs. So normally, each of the virtual machines, it has a kernel and operating system that they're running. And then inside of it, you're running an application with a binary. What it means is, in this case, let's say you're running a Python app. So you have your Python code as the app. You have the binary, which is the Python executable. And then you have the kernel operating system, which might be Windows, might be Linux, most probably Linux if you're on the server side of things. And then you have the operating system and kernel on it. And then you have an hypervisor that more or less allows to execute it safely and fast. So the main key thing about virtual machines is they don't share kernel or operating system. It has, because of that reason, very poor performance and also very low density. So imagine in one machine, you can run up to 4 virtual machines at the same time, depending on how powerful your machine is, of course. Then we move into containers. I think it's about like 12 years ago. I don't remember really when was the first time the Docker was introduced, but let's assume it's around those dates. And the main thing about the containers is they share a kernel. So what it means with this is that rather than emulating the operating system, they all have like the same kernel, usually a Linux kernel, that they share across all of them. But they still have the operating system code inside of the container. So if you are using Ubuntu or Debian or whatever, there is still operating system code that it has to execute, and it's still very heavyweight. What this means is it actually has low density. So even though like the kernel is shared, each of the containers will have its own operating system, will have its own binary, and will have the code for the app that you want to run. And then basically like the case with Wasmer is that we share both the kernel, operating system, and the binary executables. Because of that, we are able to have way higher density. So if in the example of the virtual machines, you're able to run like 4 VMs, virtual machines in your system. In the case of container, you might be able to run 8, maybe 12. In Wasmer, you might be able to run like actually like thousands of applications on your system because Wasmer is extremely lightweight. Also, it's fully sandbox and basically allows for high density. Any questions on this slide?
This would apply to Kubernetes as well as Docker, correct?
Yes,
For containers?
exactly.
And
So
Podman as
basically,
well, you know,
and what? Sorry?
Podman. I think a
Podman,
lot of
yes. So,
yeah.
so So basically, like just for the audience that don't know like what Kubernetes or Podman is, Podman is an alternative to Docker containers, different runtime, but it's able to run the same kind of containers, and that's what Podman is. It appeared, I think, a few years ago, and then Kubernetes, if basically like Docker, what it has is the instance, let's say the computer or the container running. What Kubernetes is able to do is put a lot of these containers together and to schedule them to see basically like when, let's say you have a website that is in a container, when it need to ramp up the website or when you need to put more instances of this website because it's getting more visits or anything like that. So Kubernetes is a scheduler that allows to run in multiple containers at the same time. More or less the restriction of Kubernetes in this case is more or less the same. So you don't have as much density, so it's able to run like, let's say, the dozens of containers, but it's not able to run like thousands of microservices performantly. It's basically not designed for that. So basically, like one of the things that we are seeing in the last years, especially with AI, is that modern systems increasingly execute code that we didn't write. The question is no longer if, but how to execute this code safely and efficiently. And this, for example, can happen with we use AI. AI generates code that we are not extremely familiar with, might be safe, or we want to enable plugins for whatever use case that we want to have, and we want the user to be able to create plugins for our system, or basically we are an IDE, for example, and we want to be able to run untrusted code directly. So this is one tendency that we have seen in the last years. So why this matters is in general, like especially like with AI, we have seen that the workloads that we are trying to run are more ephemeral, short-lived. So basically, the AI will generate some code, we execute it once, then forget about it. Maybe we execute it more, but it's usually like more ephemeral than previous usage of, let's say, Python. It's as well more multi-tenant. Basically, like we want to be able, if we create a website with AI, we want to be able to run it basically like almost everywhere and with high density. And the last is basically like untrusted. We don't know where it's coming from. It might be doing something harmful. So we want to make sure we are executing code that it's completely safe to run. So we need a new execution primitive. So wait, is this not a Python talk? Let's get into how all this relates to Python. So how Python is used in WebAssembly. By the way, for those of you that don't know, Wasm is an acronym for WebAssembly. They are equivalent. It's usually like written in its shorter form because it's a little bit more convenient. So there are two use cases for Python and WebAssembly. One is browser first. This one is optimized for JavaScript execution. In this case, Python is the most popular framework of using Python on the browser, and it's Python compiled to WebAssembly via mscripten. Mscripten is one special compiler. If you know what GCC or Clang is basically something like that, but allows compiling C, C++ programs, and so on into the browser. So Python uses mscripten to compile Python, the same Python that you run natively. It uses it to compile it to WebAssembly, so it can run in the browser. This Python is currently used in Jupyter Lite. Jupyter is a notebook technology that you can use on the server normally, but they enable a way of running fully on the browser, basically Python fully on the browser. Then you have pyscript.com, which I believe is a project from Anaconda, then Anaconda Cloud. And you also have Cloudflare, which is the only one that is actually using Python for the server, but they are using it through JavaScript. So that's first use case. And then is basically like for running Python on the server. And the main reason that you want to do that is because you have more density for Python applications that you can run on your own system. So you can run Python in the server, as I commented. For example, that's what Cloudflare is doing, or you can run it with Wasmer. In general, like this is used in Wasmer Edge, which is a hosting platform that we provide, and this is used by AI companies as well. So the main issue that we have seen is Python has some constraints. First, there is no support for sockets, meaning like if you don't know what a socket is, when you open a HTTP website, there are like certain operations that happen on TCP and UDP protocols. And you need basically like raw access to sockets to be able to, for example, do a ping to a direction of IP address, or for example, to connect to a database. You would need to have raw TCP or UDP access. In this case, it doesn't support it because first, the browser doesn't support it. So you are not able to run like a database connection from the browser itself. Then it has limited POSIX support. If you don't know what POSIX is more or less the underlying structure or structure of system calls when you are using a Unix platform, let's say Linux or Mac. And basically provides all the capabilities to be able to access file, operate with threads, or basically whatever you want to do in the operating system. POSIX usually enables that. It doesn't support fully multi-threading iodide, so that means that if you want to have multiple threads running even from Python, you cannot do that in Pyodide. Also, it doesn't have support for subprocesses. What this has subprocess is basically calling another program from Python. So you can call ffmpeg, which is like a video converter, for example, from Python, or you can call other binaries from Python itself. Also, it doesn't have support for greenlets. If you don't know what a greenlet is basically like async before async IO existed. This very like old school, but it's still used. And if you have used SQL Alchemy, for example, SQL Alchemy uses greenlets under the hood to be able to don't block execution of basically like database instructions on Python.
You know, an interesting use case for me is basically some kind of Jupyter server running through Wasm. I think I've seen Jupyter Lite,
Yes.
and maybe in the future, having an SSH into the remote machine and launch an extern window. That would be an interesting use case that I would like, in my day-to-day work.
Yes. That, by the way, is already possible. I can show you some things basically after the demo today, but that's actually
Oh,
already possible. And right now, Jupyter created Jupyter Lite, which is basically like a trimmed version of Jupyter, but it's not as powerful. In the case of basically like if you want to run it with Wasmer, that you will have like no restrictions. But let's not get ahead of the next slides. But more or less what we can see is that Pyodide was not designed for server workloads, even though Cloudflare uses it. Cloudflare uses it because all their platform is based on JavaScript, so they need it for their own use case. But when you remove JavaScript from the picture, there are more optimal ways of running. So why Python plus WebAssembly on the server matters, specifically or especially on AI workloads. Basically, like one of the things that we are seeing is that sandboxing is now a core infrastructure requirement. First, because we want to run untrusted Python code. Second, because we need extremely fast response times. Let's say, imagine you create something with AI, you want to run it, and it takes seconds to the startup. It will be not a great experience. Also, we need high density. Why we need high density? Because many more people have access to Python right now thanks to AI. And because of that, the requirements for running this code are more constrained. We have more or less the same number of servers, even though it's growing, but we require to run much more code untrusted from users than we were before. So one of the things I wanted to showcase is the emerging sandboxing pattern. One of the things that we are seeing as well with AI is that we want to put constraints on the resources that this AI is able to access when running Python or when running other programs. For example, we want to say maximum executed this on 2 CPUs, or maximum take this much memory, or that much execution time. Basically, we want to put some constraints on when we execute it to make sure like it doesn't overload, even though like it's way more lightweight compared to containers. Also, we want to make sure like the access is capability based. What this means is that we are able to actually specify to what file system this sandboxing primitive have access, or to which websites. Imagine you want to run Python, but you tell it, please do only use network for google.com or for these IP addresses. And I'm not going to let my Python code to access any other website. Right now with Wasmer, this is possible. Also, we need high performance, basically high density and fast startups, as I mentioned previously. So what's a Wasmer approach to Python in WebAssembly? One of the unique things that we have done is that Wasmer is both runnable on the server and on the browser. It's the same code base. Imagine you are able to run Docker containers on your browser. That's more or less what Wasmer is doing. But now I imagine your containers are so lightweight that they can run also on your phone, or you can run them embedded inside of your programs, Python programs. So imagine using Docker instead of Python and being able to basically execute whatever program you want from there very easily. That's more or less what Wasmer is. What this enables, it enables stream modifications for running your code actually locally or in the server. You don't need to adapt your code to be able to run on Wasmer. If you have a Django app or Fast API app or whatever you are used to, you can just run the same app in Wasmer, no modifications needed. Then it runs in any environment and operating system. So in the case of Docker or Podman containers, you would normally need to run like a Linux virtual machine if you are not in Linux. So that's for Mac. And for Windows, you will need to run a Linux machine. And the main reason for this is because you want to make sure like the containers are able to reuse the Linux kernel to be able to run. In the case of Wasmer, that's not required. Wasmer can run in any environment and operating system, can run in the browser, can run in Mac, can run in Linux, can run in Windows, can run in your phone, can run embedded in other programming languages, basically can run anywhere. And also it's extremely lightweight. You can run like thousands of Wasmer containers if you want. The main thing about Wasmer is specifically for Python, there is no limitations. It can run greenlets, and that means SQL alchemy. It can run multi-threaded code for Python, and it can run subprocess. So let's analyze basically like what this actually enables for businesses. Right now, when you visit when you visit a website, it's likely this website will be run using Kubernetes on one side and Docker under the hood. The issue about that is containers have a heavy isolation overhead. Mainly, they have slow startup times. So imagine each time that you want to have a web request to your website, so there is one visitor that is visiting your website, you want to turn on and off the website because you want to be optimal, right? Like you want to make sure like you don't get a bill for 1 month of execution of that server, only like for some seconds. The case for containers there is they have extremely slow startup times, meaning that in the best case scenario, which is using Firecracker, a technology that Amazon created, in the best case, the times are going to be like 400 milliseconds. But for Python, normally the startup times are actually going to be much higher. Will be like 1, 2, 3, up to 10 seconds of startup time. In the case of WebAssembly, because of the thing that I mentioned, both the operating system and the binaries are shared across all the applications that are actually like requesting to use them. But this shared execution still allows for full sandboxing. So each program that you're running is completely isolated from each other. This allows extremely fast start times and very high density. So in the graph that I have here to the right, we can see that in different providers, This, by the way, it's on. You can compare as well for Google Cloud or Microsoft Azure. The timings will be more or less similar. Will be like from 1 to 2 seconds of the startup time for a very simple Python program to start on the server. Because of these timings are high, normally you cannot afford to turn off the websites when your website doesn't get visited. One of the cool things about Wasmer is it's an order of magnitude faster to start up. What this allows is that we can actually like turn off and on your website only when it gets visits, and this is thanks to WebAssembly and all the sandboxing primitives that we have. Also, the lightweight model of Wasmer. So I'm gonna show you a demo of basically like how you can use Wasmer today. So first, I will start with going to the Wasmer website. I believe we have something like SDK. So here you can get like the command to install Wasmer if you want locally. And let me just create this new tab. Hopefully this will be a good size for all of you. So first, let's say we want to install it. Just run this command. In this case, I already have it installed, so the installation aborted. But now you should have the command available on your shell. So you have Wasmer, for example, 7.0.1. We released this version a few days ago. And now we want to be able to run Python. So the only thing that we need to do is Wasmer run Python. And I'm sorry, this, because I'm in development mode, normally I need to specify the registry. That's something that you don't need to do. You just need to do Wasmer run Python. And here we can see like the full Python terminal, basically like working here. You can do whatever you normally would do. If we want to do the example of that we were running before, I forgot how it was, but
So this is analogous to running things in Docker, right? You do a Docker
yes.
pull,
Okay.
and then you start the shell.
How do you
Yeah.
do
So
this installation of packages this way?
automatically, you don't need to handle it. If you mean for Python packages, basically
Yeah.
like we have one thing that right now is not released that we call like ship it CLI. So basically like when you have a code base that already works with Python. So let me go to some examples that I have here.
So I have a module that I've set up a Pi project at Telmel with it. You
No,
know.
yeah. So basically, the only thing that you would need to do, if you want to run this locally, let's say I want to run fast API.
Hmm.
I have an example here of fast API. I have UV installed. UV is a package manager for Python. It's more or less the most modern one. I recommend using it. So I'm gonna use UVX, which gets included with UV, and I'm gonna call ship it CLI. And now I'm gonna say like basically run this folder and run it with Wasmer and start the website. So if you do this with your project, it will basically like install your projects for Wasmer. Like first, like yeah, it will detect what all the dependencies are, install the dependencies for Wasmer, and oh wait a second. This again, you don't need to do it; it will work seamlessly for you. Here we go. So it's installing the dependencies. So one of the special things about this is that you don't need to worry about running it with Wasmer or not. Basically, we automatically detect your dependencies. In the case it's a Python project, we are able to install and optimize them. And now basically I have my fast API example here running locally. And I didn't need to do anything. Now it's running with Wasmer, it's running great. But what's cool about this is that it can actually as well run on the server. So as I mentioned, when I started, Wasmer has one platform for hosting. This is incredibly affordable. Basically, like having a website is so affordable that we can offer free hosting for Python for basically like almost everyone. And then once your usage gets up, it will be like you will need to pay, but basically like you have a very generous free tier for using Python on the edge or on the cloud. And I'm gonna go through, for example, like how this thing works, but it's powered by the same thing that I mentioned before, or that we have seen here. Basically, it's powered by the same technology. So right now we are gonna go to the templates. We are in wasmer.io. I'm gonna choose the Python templates. For example, we are gonna use the example of Fast API plus SQL Alchemy. Fast API is a way of basically creating APIs in Python, and SQL Alchemy is a ORM that allows us to create databases or interact with databases and create tables and so on. So here I have this template. I'm gonna deploy it in Wasmer. Cool. So I'm gonna do here demo for CalPy. I'm gonna basically I already have GitHub connected. If you do this for the first time, you will need to connect your GitHub. But what this is gonna do is basically like create me a repo first in my GitHub and put the code of the Fast API example that we want to run. So again, here is basically like the Git repo being created. This project is special because it's not only a Python project that actually executes a server, it also runs Alembic, which is used for running migrations, meaning creating tables that your project might need and so on. So first step is just creating the GitHub repo. That was more or less a trivial part, but now we want to deploy it. So I'm just going to deploy it. You're going to see how long it takes. So the same thing that I've been basically running locally, now I can actually run it on the clouds. We can see that now like the application is ready to be deployed and is ready to be deployed to this URL. It created a MySQL database for us and so on. And basically, like after this, we can see that the Fast API example should be fully working. So let's see. Here we have. This is how long it takes, by the way, to deploy a Python website in Wasmer. It should be incredibly easy.
Okay.
So here is, for example, yeah, go ahead.
No, this looks interesting.
So right now, for example,
to me, this still
this
feels
is
kind of like hand waving, right?
So a little bit like what?
Hand waving. In other words, it looks very cool, but I don't really understand what is going on behind the scenes, right?
So
is this a binary on your server?
No, it's the same. It's the same program that you have locally. The only difference is rather than using Docker containers under hood, is using Wasmer under hood. And because of that, basically Wasmer is able to run like thousands or we got not yet a million applications per server, but we are getting close. So we are able to run a lot of applications in the same server with basically like very, very very little cost. Yeah.
Yeah, what I do right now is I use a reverse proxy, right? On my server, and then I run the Python binary, and I give it my fast API script, right? And then because the Python binary is executing on the server with my script, it takes a port, and that port is the port my application is running on, right? It's not running in a container. It's just running
On your server.
VPS, right?
Yes.
So I'm trying to picture what's
the difference?
Yeah, how do these Wasmer things actually work? There is no.
Okay. So basically, like then when you have the case that Robert mentioned is it has a reverse proxy that more or less like gets the request from the internet, and then it points out from that I don't know whatever point into a VPS, into a virtual private server that Robert has set up that basically is running for the whole month. Let's say you're paying I don't know, maybe $10, maybe 20, depends on how powerful this VPS is. But basically,
Six
you're
bucks.
paying. Okay, perfect. So it's actually cheaper. So you're paying $6 per month, and you have a server that is usually like not super powerful, but is powerful enough for your workloads. And basically, like it runs fully. Like basically, it's a server that is running all hours. Is available like at any time. It's always on. And basically, like this reverse proxy detects a request and then sends it to their virtual private server. How this differs from Wasmer? Basically, like in the case of Wasmer, rather than having your site running constantly, like basically like for a full month, we only turn it on when a new request happens. So we only turn it on when certain events happen. Because of that, basically, like we are able to have again like higher density of applications on a server, and we are able to run a lot. But basically, the TLDR is that we can now, like thanks to the technology that we have created, we can afford to turn on and off the website without limitations, more or less. Imagine like you're in Windows and you put in hibernation, right? Basically, like when you put things in hibernation, so the next time that you turn on the computer is exactly at the same point. We do something similar for your webs, but this turn off and turn on, basically like pause and resume execution is extremely fast. So it just takes a few milliseconds. So that's more or less what we do and what the difference is. Does that make things clearer?
Yeah, so that sounds kind of like Amazon Lambda, right?
Lambdas, exactly. Exactly. It's like Amazon Lambda, but actually like way way better. Why is better than Lambdas is because we actually allow like WebSocket applications. You can run any kind of application without having to adapt to a custom API that we have created. You can run your fast API code as you want without worrying about any wrapper or anything like that. It can run WebSockets. It can run like LangChain, for example, that uses WebSockets to be able to chat with things. So in this case, this fast API application, basically like it's a to-do app. So I'm gonna jump back into the example. I'm gonna add here like buy milk. Then basically like we are gonna add it. Then buy Twitter, and for this 6 billion. I don't know. Basically, like we are gonna add, we can mark it as done and so on. But one of the coolest things of Wasmer is that we have like a dashboard, and in this dashboard, actually, like you can see how many requests. Sorry, Patrick, can you mute? Thanks. So here we have like the website. We can add our custom domains. We can actually like see a database that was created for us. We can go to the DB Explorer. By the way, this DB Explorer is another serverless application. In this case, is not powered by Python, but by PHP. If you know what PHP my admin is something very similar. But here, for example, like we can see the things that we have created here on our app. We can see the contents and the tables and so on. And yeah, basically we can modify the settings. We can do basically whatever we want here. So these are the demos that I wanted to do. And basically, like one of the things I wanted to say today is if you have attended this and you like what you are seeing and you would like to experiment with this for your Python projects and so on, we want to give you 1 year free of Wasmer Pro account. This it occurred to me when I was chatting yesterday with Woody and Robert, but we don't have basically like a referral mode. So the only thing that or one way to put like discount codes. So one way that we can get this working is just create an account in wasmer.io and just reach me by email and ask for the 1 year for free. Give me your username, and then I will basically give you the 1 year for free for your account, so you can start using it. And that's it. That's my handle on X or Twitter, and here is the company handle as well. Just kind of like a closing point is right now this technology that we have created, it's enabled like certain AI providers that are creating like a lot of Python applications for their users. And we are able basically like to run like more than 500,000 applications with our system in just a handful of servers. So it's extremely optimal. And yeah, this technology again applies not only for the browser, but for the server, and it's for allows for very interesting use cases. One of the demos I wanted to do today, but I could not fix it because I was tired yesterday and I just left for hours, is that I wanted to show you like the same thing running on the browser, which by the way is fully possible. It's just we migrated our website and there is a small issue that is not yeah, just doesn't enable that. So but yeah, basically like everything that I showed and I commented can run on your browser, even servers. So imagine being able to run Fast API or Django fully on your browser, no server required whatsoever. So actually you can even run your app offline. We would enable that as well. I don't have the demo already, but you can hopefully trust me that this will work. And that's it. And that's the presentation for today.
I was just thinking, do you see a use case for Wasmer replacing sort of beefy browser-based GUIs like Electron for a lot of functionalities? That could be very useful, for me.
Yes. So yes, it's still a little bit early on that front. There is one project that actually was doing that. It's a little bit early because you need to have access to the UI, kind of like universally across like any operating system like Linux, Windows, Mac, or even the phone. But yeah, basically we have seen one project. I forgot what was the name of it, which was using WebAssembly for exactly like that use case, replacing Electron.
Very cool. Any other questions for Syrus? Awesome. Well, thank you so much, Syrus, especially for, gritting it out starting at 4 a.m. Brilliant presentation. I look forward to playing with that. And I've posted the link and the email in the chat. I'll follow up in the meeting groups to make sure people have that. But I'm definitely going to play around with this. This looks great.
Awesome. I will also send the slides of the presentation to you, Woody, so you can share it with whoever you want. And I will basically put a link on this online as well. So feel free to follow if you want
Will
to learn
do.
more, or feel free to reach me if you have any questions or you would like to have the 1 year of the pro account for Wasmer.
Beautiful. Will do.
Really cool.
Yeah. All right. Well, thanks
Awesome.
everyone. Thanks
We'll
again.
go back to sleep now.
Thank you.
Yeah, get some sleep and safe travels, okay?
All right.
Thanks.
Bye-bye.
See you. Bye.
All right, bye everyone.